Earth Systems 3209, Unit 3, Earth's Materials. References can be found for Unit 3 in Chapters 2, 3, 6, 7, Appendix A and Appendix B in the Curriculum Guide. Unit 3, Topic 4.6. This topic will look at biochemical sedimentary rocks, and will focus on identifying the processes that form biochemical sedimentary rocks, and also focus on identifying the different biochemical sedimentary rocks and the environment in which they form. If we look at biochemical sedimentary rocks, biochemical sedimentary rocks are sedimentary rocks created when organisms use materials dissolved in air or water to build their tissue. Therefore, biochemical sedimentary rocks are rocks that result from once living organisms. Some examples of biochemical sedimentary rocks include a rock called Queena, chalk, chert, limestone formed from coral, and also coal. Let's take a closer look at the chemical sedimentary rocks that fall under the category biochemical. The first example of a chemical sedimentary rock that is biochemical in nature is Queena. Queena is an organic rock of biochemical origin, and it forms from the buildup, compaction, and cementation of shells and fragments of shells of dead organisms. So if we look to the right, here we see a rock sample that's made up of fragments of shell fragments that basically are cemented together. And if we look at the magnified version of it, we can see that there are plenty of little shell fragments that are all compacted and cemented together to form the one big solid rock called Queena. The second example of a biochemical sedimentary rock will be a rock called chert. Chert is a name given for a number of very compact and hard rocks made from microcrystalline silica. For example, chert can be in the form of flint, jasper, or agate. To the diagram to the right, we see an example of a chert that takes the form of agate. And in this rock, we can see many layers of the silica that forms within a void in a solid rock. These are nice looking rocks and are usually sold for ornamental purposes. Chert also form mostly in ocean environments. Chert can occur in layers, such as beds, or it can occur as an irregular blob within limestone. Chert also forms from marine creatures such as diatoms and radiolarian, which remove the silica from the seawater to make the shells. And once these organisms die, the diatoms and radiolarian, which are microscopic, will settle to the bottom of the ocean, where it forms a siliceous ooze. And over time, once this siliceous ooze gets buried by other sediments, they will form into a solid rock, which we call chert. The third example of a biochemical sedimentary rock would be limestone, which results from coral. Creating large quantities of marine limestone from their shells, corals basically use their external skeletons, which are composed of calcium carbonate. And once the coral dies, it can actually build up and form layers of limestone. Coral fossils are commonly found within this type of limestone. The fourth example of a biochemical rock is chalk. Chalk is formed as a result of the buildup, compaction, and cementation of microscopic marine organisms that are made up of carbonate. These organisms are called foraminifera. So foraminifera, when they die, again, settle to the bottom of the ocean, and an accumulation of these foraminifera can get compacted to form the biochemical rock called chalk. A fifth example of a biochemical rock is coal. The end product of large amounts of plant material that has been buried and chemically altered over millions of years will form a rock called coal. And coal can advance through different stages, which will be studied in another presentation. So coal is the fifth example of a biochemical sedimentary rock. If we look at the environments in which these biochemical sedimentary rocks form, the first environment will be a swamp environment. Swamp environments or bog environments where there is vast amounts of vegetation, these will potentially form into coal if conditions are right and the swamp or vegetative environment gets buried by sediment. The second environment could be a shallow marine environment. Shallow marine environments, such as shallow oceans like the continental shelf, can form an environment where you find rock types such as Queena and coral limestone. These two rocks are found in a shallow marine environment, such as those neighboring coastlines in shallow water environments like the continental shelf. A beach environment would be more conducive to forming the biochemical rock Queena. As once all the shell organisms that live in the shallow marine environment die, these marine organisms that have shells can actually break down into fragments, and all the fragments can then be washed ashore, forming beach environments. Such beach environments are commonly found in tropical areas. And a fourth environment would be a deep marine environment. Deep marine environments are more conducive to forming the microorganisms, microscopic organisms that form chalk and chert. Foraminifera, which are calcium carbonate in composition, once these organisms die, they settle to the bottom of the ocean and they can form chalk deposits in a deep ocean environment. Other organisms such as diatoms and radiolarian, which take silica from the ocean water, can actually die, and when they die they settle to the bottom of the oceans in deep ocean environments, and they can form siliceous oozes, will then form into a solid rock called chert. Let's have a look at some examples. Example number 1. Which is a biochemical sedimentary rock? Our choices include conglomerate, chalk, sandstone, and shale. Once we look at all three, the question asks for a biochemical sedimentary rock. And we see that conglomerate, sandstone, and shale are made up of particles, and they are called clastic rocks. Therefore, the answer to this question will be chalk. Chalk is a biochemical sedimentary rock that is made up of microscopic organisms called foraminifera, and when they die, they settle to the bottom of deep ocean environments where they compact and form chalk deposits. Example number 2 reads, which biochemical sedimentary rock is made from microcrystalline silica? Our choices: Queena, chert, coal, and limestone. Even though all 4 examples can be examples of biochemical sedimentary rocks, the one that is made from microcrystalline silica would be chert. And chert is a result of microscopic organisms such as radiolarian and diatoms, which die and settle to the bottom of the ocean in deep ocean environments where they are eventually compacted to form a solid silica rock called chert. Your turn. Take the time and complete the following question. The solution will follow on the following slide. You can stop your recording now to prepare your answer. The question reads, which biochemical sedimentary rock seen to the right was deposited in a shallow marine environment? So if we look at the diagram to the right, we see that this diagram is made up of many fragments of shells that are all cemented and compacted together to form a solid rock. So when we look at our choices, we have Queena, coal, chert, and jasper. We see that coal forms from once living plant material. Chert and jasper are two forms of silica, microcrystalline silica deposits. So the answer to this question will be A, Queena. So Queena is a rock that forms from the cementing of many shell fragments that are all cemented together in a shallow water environment. So the answer here is Queena. An overview of the points covered. Biochemical sedimentary rocks include such rocks as Queena, chert, limestone, chalk, and coal. These rocks can form in different types of sedimentary environments, such as coal can form in a swamp environment. Shallow marine ocean environments can form limestone coral and Queena. A beach environment would be more conducive to the formation of Queena. In deep marine environments, you could form such rocks as chert and chalk, which are made from microscopic organisms that die and settle to a deep ocean environment where they form solid rocks. Therefore, this slide outlines the different biochemical sedimentary rocks and also outlines the environments in which we find these biochemical sedimentary rocks.